Okay, so the table given below describes the behavior of f dash x, the derivative function of fx, in the domain -4 to 2. Okay, so I'm just going to draw out here my x values. So my x values go from -4 and then up to 2. And the important bits along the way are -2, about there. And what else? 0? No, 0 is not on there. And 1. So they're my important points that are described below here. So let's just get a different colour. Okay, so between -4 and -2, this means the gradient. So the gradient is less than 0. So that means I've got a negative gradient here. At -2, I've got a gradient of 0. From -2 up to 1, the gradient is greater than 0. So this is a positive gradient. The gradient is 0 again at 1, and then the gradient is positive again. So this between 1 and 2, the gradient's positive. So roughly what this function looks like, we've got 0 gradient here, negative gradient before it, and a positive gradient afterwards. And then here we've got a negative, sorry, there we've got a 0 gradient, positive leading up to there, and positive coming away from there. So here and here we've got our stationary points. Okay, state whether f0 is greater than, less than, or equal to f of -2. Well, here's f of -2, and here's, sorry, and we are going to use 0. Here's 0 here. So this one is higher up than this one. So what we can say is f of 0 is greater than f of -2. It says give a reason. Well, essentially the reason is this here. Okay, because the gradient between -2 all the way up to 1 is negative. Sorry, the gradient is positive between these two places, so it's from -2 up to 0, it gets bigger. So I guess I could just say that the function is increasing from -2 to 1, which is this bit of information here. Okay, the point 2,3 lies on the graph of fx. Write down the equation of the tangent to the graph fx at point P. Okay, so, well, the equation of the tangent to the graph, okay, so we need the, first of all, we need the gradient of the tangent. So the gradient at x equals -2. So to do that, I'm going to have a look up here. The gradient f dash x at -2 is 0. And a line with a gradient of 0 is, oh, whoops, that's not very well drawn, is a horizontal line. Okay, and horizontal lines, the equation is going to be in the form y equals, because it's going to have the same height all the way along this line, and the height from this coordinate, the height has to be 3. Okay, so that's one that we have to do just from our knowledge of horizontal lines, and the fact that we've been given the gradient at -2 is 0. Finally, part C. From the information given about f dash x, state whether the point -2, 3 is a maximum, minimum, or neither. Alright, well, we've already drawn our diagram here, and we've shown that it is actually a minimum. Give a reason for our answer. Well, I guess our sketch would help. You could either say, well, the reason is because the gradient is negative between -4 to -2, and the gradient is positive from -2 to 1. And just draw a sketch just showing that this is our negative gradient, this is -2, and this is our positive gradient.